Hello everyone, welcome to our group project showcase. My name is Kanishka Dhindhwal and my group members are Palash, Kadam and Karan Sharma. We would like to present our project to you, which is text summarization using SBOT. So as we all know, in today's fast-paced world, the volume of reading material can be very overwhelming, especially if you're trying to stay informed. Wouldn't it be great to get quick, accurate summaries of articles without missing the key information? Well, that's exactly what we're tackling in today's project using machine learning. So let's dive into the challenge we're addressing, which is the need to summarize long articles quickly and effectively. By using BERT and other natural language processing techniques, this project focuses on creating an automated system that can generate concise and relevant information summaries, saving readers' time and efforts. So now let's talk about the heart of the project, which is BERT. So BERT stands for Bidirectional Encoder Representations from Transformers, and it's state-of-the-art deep learning model. So unlike other older models, BERT treats text bidirectionally. This means it looks at the word before and after a given word in a sentence, helping it capture more complex relationships between words and understand the full context. So now, like we can see, here's the code to set up our system. First, we see we're using here Spacey, which is a popular natural language processing library to load a pre-trained language called N-core web language, which is here. Then this model helps us process the text of the articles. Next, we use a BERT-based model called sentence transformer to embed or convert each sentence into the format that computer can work with. Specifically, we're using Dispert base Lee mean tokens version, which is faster, lighter version of BERT designed to handle text embeddings. So once we have these embeddings, representations of sentences, we can start building the system that will identify the most critical information from an article and then generate the summary of it, capturing the core message out of the article very accurately. And that's how we see BERT's ability to understand word relationships from both directions, which makes it incredibly effective for this task and making it even better. And so from here onwards, we will continue with the further steps that makes our project. My group members will continue.
To start with the project explanation, first we'll take a look at the code and we'll be going through it step by step. The first step would be data pre-processing. That would include processing the data and cleaning the data that we have obtained from the data source, which is Kaggle. And from Kaggle, we have obtained the data, which is CNN data mail that includes various articles, their summaries, and their headlines. So let's start. We start by importing the necessary libraries and adding helper functions from a specified path as shown in the code over here. And then we clip the number of data, training data samples that we want to train our model on. So here we have used 5,000 as the training data count due to the computational li limitations that we had to face. And after that, what we will be doing is we would be creating a data frame from the training set data and limiting it to the first 5,000 samples as mentioned in the following code. After that, we would load our NLP model and the sentence embedder. Here, we are using Spacey's large English model and the Distill BERT model from the sentence transformers library. So after that, we record the time to measure how long the embedding process takes. Going further, here we have the code to extract and clean the sentence and prepare the sentence embedding for each article. Okay, after that, we'll move on to the next script that we have, which is for pre-processing the label targets. Now, moving on to the second part of the code, the project, which is the second script, pre-processing label target. In this, the script would pre-process labels for summarization tasks. So let's dive right in. First, we import all the libraries that we would like. Then we have two helper functions, one of which is find sim single summary, which returns an array of indices for max cosine per summary sentences. Then we have label sentence summary, in which the which labels the sentences in the documents that are most similar to the summary sentences. It returns indices and binary target labels. Moving on to the next part of the script, which is the main part of the script, we define the output file name and load the data frame from a pickle file. Next, we get the indexed list and target labels by applying our helper function to the text and summary embeddings over here. And after that, we would update the data frame with the labels and index list. Finally, then we save all the data that we have in the updated data frame to a pickle file and print the time taken for the entire process. Now we'll be going over the script, add additional features. This code this code or script preprocesses a data set by adding additional features to each document sentences. It also would calculate the mean embedding and sentence length for each document, then creates new features for each sentence, including the document label, mean embedding, sentence number, and document length. The process data is then saved to a pickle file so that we can use it for the further scripts. So let's start by a quick look at the code. First, like in every script, we will import the required libraries and then mention the output file name where we would like to output the data from this script. Then we load the data to a data frame from the pickle file. After that, we would define features and label as separate series, like shown over here. And then we would label the documents and calculate the mean embeddings and sentence length for each document. Next, we create values for each sentence in the document, as mentioned in the code over here. After that, we convert the lists into Panda series and then concatenate the documents with rows representing sentences. And finally, we wrap the features in a data frame with appropriate labels and save the updated data to a pickle file and print the time taken for the entire process. That is all that we do for this script.
So now in data exploration, we compute the mean of both the columns, which gives us a quick look at the average of the length and the summaries. And now by calculating percentiles to understand how article and summary lengths are distributed across different ranges, we calculate the key percentiles such as 25th, 50th, 75th, 95th, 99th, and even the maximum. So we can see the variations from short articles to the longest ones. We then create a regression plot showing the relationship between the article length and the summary length. This helps us if longer articles tend to have longer summaries. Then we use TSNE to reduce the dimensionality of the document embedding down to two dimension so we can visualize them. The scatter plot shows us how articles from different domains like politics, crime, then entertainment, business, culture, cluster together in the embedding space. Finally, we analyzed sentence from the article which are most likely to appear in the summaries. So this plot shows us that around 50 sentences are more likely to be included in summaries, emphasizing the importance of strong introduction in new articles. So this was the quick breakdown of the article embedding, then domain breakdown, then summary, statistics, and visualization using TSNE and regression.
To add domain label to our articles, we initialize the sentence embedder using the Distilbert model from the sentence transformer library. We then define a lambda function to embed text using the embedder. And next, we define subject domains and find their embeddings using BERT. We calculate the cosine similarity between each article and the subject domains. And there is a function to return the domain with the highest cosine similarity for each article. Then the domain labels to the primary data frame is added and the pickle file is updated. After adding domain labels to our training data, we move further with splitting the dataset into trained test set with 80-20% ratio. Moving on to the actual implementation, we are using logistic regression, which actually decides whether a sentence will be a part of summary or not. So we start with fitting the logistic regression model with the training data, and then we predict the probabilities and convert them into binary predictions. Further, we calculate the confusion matrix to evaluate the model's performance. Now, we return the predicted summaries using our helper function. And then we match the predicted summaries with the gold summaries, which is used to calculate the rogue score.
That concludes the presentation for our project for this project, and these are the outputs that were generated for the summaries. The model that we used was evaluated using an 80% and 80% training and 20% testing split, but with a relatively small data set of around 4 to 5,000 training samples, which likely contributed to the lower accuracy. This limited data size was due to restrictions on the computational power, which prevented the use of a larger data set. As models generally perform better with larger amounts of data to learn from, we would have loved to train this model on a larger data set and get better accuracy with the same.